Hi, today I'll be talking to you about some advanced topics in the InterSystems Package Manager. My name is Tim Leavitt. I'm the Development Manager and the Application Services team at InterSystems. Some of the things we'll be talking about today, really a smattering of unrelated topics. The ability to have a self-hosted package registry and a proxy to the main community registry. We'll talk about extensibility in a number of different areas for different sorts of resources that are part of your application beyond just simple classes, routines, about different options for packaging, again, particularly beyond the normal object script areas, and also extensibility in different sorts of registries that you might connect to. We'll also talk about some use cases and continuous integration and continuous deployment. Coming out of this, you should be able to understand proper control and use of the InterSystems Package Manager in an enterprise setting, and powerful extensibility for use cases beyond simple object script projects. The key thing I'd like you to get from this presentation is that the InterSystems Package Manager is not just an easy way to get community-driven tools and examples. It's a key enabler for many aspects of the development process. So jumping right in with self-hosted registries and the proxy feature. This is all using the ZPM registry package available on the main community registry. So on the IRIS instance that you would like to act as your package registry, you just run ZPM install ZPM-registry. And there's a bit more configuration we'll get to, but that's how you start out. And then on any instance you would like to connect to that registry, you just set it up as the repo to use instead of the main community registry. And you can see the command for it there. You can publish to this registry two ways, through CURL or your HTTP client of choice, just saying this is a GitHub repo that I would like to include in this registry. And note that basic authentication is required for this. You can also publish through the package manager shell with the package name publish command, and we'll demonstrate that in a bit. If you would like to have your own registry and also provide some content from the main community registry, you can do that through a proxy. So to do this, create a file named zpm-registry.yaml in your instance's install directory, not the MGR directory, a level up from that. And you can see an example there. You have a list of uplinks with names. In this case, PM points to the main community registry. And there's a comma-separated list of packages that are allowed. There's also a wildcard syntax that's allowed for this, but if I want to control this, I'm just going to explicitly list the packages. So let's go into a demo of a self-hosted registry and proxy connecting to the main community registry. When you install the InterSystems Package Manager, right off the bat, it's set up to communicate with the community registry at pm.community.intersystems.com. From there, I've already installed the ZPM registry package, and I'm now going to set up my namespace to use it by running the repo command, updating the existing registry, and using the URL localhost 52779/registry. Now if I run the repo list command, I can see just my local registry. And if I list the packages available there, there's nothing right now because I haven't published anything there. So as a starting point, I'll publish something there. If I go over to Postman and I post a JSON object with repository set to the URL of some GitHub project and send that, got a good response back. And if I run this again, I can see object script math version 0.0.5 is available there. And I can even install that. Next, say I want to make some packages from the community registry available through this local registry. I can define a file named zpmregistry.yaml in the IRIS instance's root directory. So in this case, it's C InterSystems Python. It's my instance name. So we'll say we have an uplink to the main community registry at pm.community.intersystems.com. And we'll just allow 4 packages: test coverage, apps.rest, deep-c web, and mdx to JSON. I can save that, and then I'll run the same command to list what's available again, and I can see it's updated and those 4 packages are included. Next, let's talk about extensibility a little bit. A real complex object script package is not just classes, routines, and include files, but might also include, say, a web user interface or other aspects that are in technologies outside of IRIS. There are built-in tools in the package manager to handle some of the simple cases here for web applications. There's a file copy resource type that'll just say, take these files from the package and move them somewhere else within the instance or machine where the instance is running. There's the option to automatically configure web applications with settings, say, based on the current namespace and with static content from the package. And there's also an invoke command that will let you just run any object script class method with specified arguments at any phase in the package's lifecycle. This will let you do pretty much anything you want. For greater reusability, there's also the option to define a custom resource processor. So we'll look at an example in a bit for driving an npm install and Angular build through this. The benefit of wrapping all this in a custom resource processor is that you don't need to write out the same set of invoke commands in a bunch of different places. And it just makes it easier to integrate whatever other external tools you want to drive through the package manager. Speaking of that Angular build, consider that we package one of our packages with this command, package, project name, and this dash verbose flag is worth mentioning. You can really put that in any package manager shell command, and it'll give you verbose output as to what's going on under the hood, which is helpful if something's going wrong or if you're just curious what's actually happening. By default, packaging creates a tarball that mirrors the repo structure. So to install a package, you just extract and then load the same way you would normally just from a git clone, for example. However, in these custom processor classes, you can override the onExportItem method to customize the behavior when that artifact is created. So in our motivating use case for an Angular build, we'll exclude the source from the artifact and we'll include the output of a build process that runs in the compile phase. This means that as a developer, when you're working on or packaging the package, it will run the Angular build. And as a consumer, when you're installing it, you don't need to. So there's not that additional external dependency, and it's quick to install, and it's deterministic because we already have the built artifact. Speaking of artifacts, suppose you don't use GitHub, you want to store or retrieve your artifacts from somewhere else. The InterSystems Package Manager can support that too. I've just pointed here, you can see the link in the PowerPoint, to a pull request and a sample implementation that's linked there at just how we do this under the hood for the community registry or the ZPM registry package format. The same approach could be generalized to deal with whatever other tool you use to store your build artifacts. So let's go into a demo with a couple different areas of extensibility that we've talked about. A few motivating examples. I'll talk about the Git source control package, which my other session covers, and also the motivating use case of an Angular build with an associated REST API that's running in IRIS and having that all packaged together. Let's look at some motivating examples for some of the options for extensibility and customization of the package manager beyond just dealing with classes and routines and include files. So for the first motivating example, we'll look at the Git source control package, which is the topic of my other virtual summit presentation this year. You can see that it includes a package with a bunch of classes, an include file, but also some other things. There's a directory /test within the package root that contains unit tests and the package unittest.sourcecontrol.git. These will be run automatically when you test the package. There are some other things too. There are some files that need to be copied to the dev user studio templates directory in the instance root to be served over CSP. And you can see there are two specific files that are copied to the Git source control directory underneath that folder. And then also an entire directory that is copied and overlaid there with this overlay equals 1 attribute. And that means don't clear out the directory contents before copying there. There's also a simple invoke element down here that says call the output configure message class method of the class sourcecontrol.get.utils. And this happens at the beginning of the configure phase during installation. So just looking at this, for example, I've run an install of this package with the verbose flag. You can see it loads and compiles a bunch of classes. It copies over some files and a directory, and then it outputs a message here that comes from that invoke element. For a slightly more complicated example, let's consider another project that includes an Angular UI that we want to drive building through the package manager. So you can see a slightly more expanded form for representing the package's resources here. There is a custom processor class apps.ngbuild.processor. And we're not going to go into the details of that. But in short, that drives an Angular build. So during the compile phase for the package, we will compile the Angular UI. The other thing that this is able to customize is what we do when we create an artifact for the package. We don't want to include all of the Angular source, and we don't want to have to rebuild it every time we install in a different place. So let's see what this looks like in action. Here I can see I've just run a load of this package from just a Git repo clone. And it's got some dependencies that are already installed. It moves some files over early on in the build process. And I can see in here during the compile phase, it runs an Angular build script and produces some files that are the artifacts of the Angular build. That took a little while, so I'm not going to include watching that run in the demo. At the end, I can see that it copies over the built output from the Angular build to a directory in the instances root, clears CSP gateway caches. There's more details on the copy there. And then there's this message at the end that says you can view the line-by-line monitor at this URL. So happen to have that already. Something funky's going on with my icons, but the important part is I can look at this and I've got the Angular UI up and running along with REST APIs, all of which are part of my package. Now, if I want to take this and install it somewhere else, really we want to automate that using the package manager as much as possible, and we can do that. So from this namespace in which I've already loaded it, I'm going to go into the package manager shell, and I'm going to say monLBL viewer, the name of my package, package, and publish. And I only want to do those things. I don't want to run the whole Angular build again. I've already done that. And we'll do this in verbose mode as well, so you can see what's happening. So this produces a .tgz file, and I can see that it's been published. And now if I run repo-list modules, I can see that monLBL viewer is available in my local registry. Now I'm going to get out of there and switch to a different namespace where there's nothing yet. Yeah, nothing installed. The registry setting is instance-wide. I can see that I'm set up for authentication against this, which is what allowed me to publish it. You can't just publish to the community registry, for example, whenever you want. There's a process for getting in there. I'm going to say install monLBL viewer. So there's nothing here. It's going to need to pull in some dependencies and compile those. It's figuring out what all the dependencies are and where to get them right now. So it pulls in this apps.ngbuild package, apps.rest, and the line-by-line monitor viewer. And now I'm given this URL at the end where I can just say, there it is running in my new namespace. Everything, build Angular UI, REST APIs. We didn't need to rerun the build on installation. Finally, I'd like to cover a couple use cases for continuous integration. You can use the InterSystems Package Manager to build and test your package. Particularly useful in this sort of setting is the ability of the ZPM command to accept additional colon-separated arguments, specifically for use from the OS shell. So what this will do, if you run ZPM, a quoted command, :1:1, it will halt after completion, And if something goes wrong with that command under the hood, it will terminate with an error code at the OS level. Both of these things are useful when calling in from a build script. I've included links to a couple samples, 2 for GitHub Actions, 1 for Travis CI, that use this pattern. And really, the same approach is generalizable to whatever approach you're using for continuous integration. So we'll just go through a simple walkthrough of one of these examples. Let's just talk through a simple example of a continuous integration script using the InterSystems Package Manager. This is one that runs in Travis CI. Really, the same principles are applicable to whatever tool you're using, GitHub Actions or GitLab or Jenkins, whatever your preferred CI is, the same techniques will apply. So in this case, we're using Docker. We have a container image that we're referring to, and in this case, the InterSystems DC/IRIS community containers have the InterSystems Package Manager included in an IRIS community container, so it's a great place to start for something like this. We have an instance name, we have a package name, and really everything after this should be fully generalizable. You copy this, you put your own package name in, it should work. We have a verbose build just so that we can see if any errors occur, what the full context is, and a whole bunch of stuff related to unit tests to say we'll collect test coverage, we'll report unit test results to an JUnit format. We'll treat unit test failures as a failure in the OS return value from the command to run them. And we'll collect code coverage in Cobertura format, which is another popular code coverage tool for Java, and that makes it easy to import the results into other technologies, in this case, codecov.io. So all we do is we start up the container, we wait for it to be ready. This loop waits for it to be ready. We'll install the test coverage package as a prerequisite and work around some permissions requirements for the output we'll produce. And then it's just a ZPM load with those arguments, the 1 and the 1 that I mentioned earlier, and similar ZPM package name test with all those flags from the environment variables earlier. And that's it. And we publish to codecov.io at the end. So I can see here the output from running this. It loads my classes. It loads all the unit tests and runs them. And there are a lot of unit tests. And we can see at the end that it has 100% coverage with these unit tests. So that's really great. Not really going to happen most of the time, but in this case, we have that, and the results are published to codecov.io at the end. Hopefully this has been interesting and useful, and maybe prompted some consideration of how some of the processes you are lacking or have implemented in different ways could be met through the InterSystems Package Manager. For some next steps, I'd recommend checking out the Open Exchange for all sorts of great tools and examples. If this has just been over your head and you have no idea what I'm talking about, it would be useful to go through the Package Manager articles on the developer community to catch up on the basics. And if you're particularly interested in CI, I have a developer community article also linked in the PowerPoint that goes into a deeper dive. And feel free to connect with me through email or LinkedIn. Thanks for tuning in.